Identify the details that describe the multiple triangles, in other words, the parts that overlap, and use SOHCAHTOA to travel between triangles. Travel. Remember before I did that little exercise with you where if I have a square or a pentagon and all that stuff, you know what I'm talking about, right? If you can figure out one triangle and move on to the next triangle and move on to the next triangle, we're good. And that's what I'm trying to get you to do. All right, let's do this. 2 apartment buildings. I need you to draw this. This is going to be this. I think. Yes. Okay. So I have 2 apartment buildings, 75 meters apart. From the top of the shorter building, you have an angle of elevation and an angle of depression. I'm going to give you 1 minute. See if you can draw a picture that matches that description. Okay? Go for it. What's up? Any other? Well, today is 16, so 17, 18, 19, plus 26.
Mr. Kim, I left that sheet at my house with my tutor.
Well, this for now. Hey, what's the picture look like? Yep. Well, there's obviously 2 buildings, right on? I see Rory decided to draw the larger building first. That's okay. It clearly has a height difference because the question does mention from the top of the shorter building. One of the buildings is shorter. Next, the 2 apartment buildings are 75 meters apart. Okay? From the top of the shorter building, there's an angle of elevation of 40. Remember what we talked about before? You're looking out. Okay? Angle of elevation, right? Your mouth opens up, and angle of depression, your mouth is opening down. I don't even know how else to describe that situation. But if you are here, okay, that's my stick person thing. It's not a good job, okay? And you're looking forward. Let's do it this way. Okay? The angle of elevation to the top of the building is 40 degrees. If you are confused of where the 40 degrees goes, you need to sort of chew on the idea of angle of elevation again. This shouldn't be a mystery because they specifically say angle of elevation. Angle of depression, 31. Angle of depression to the bottom of the other building. So from here
Would that be another triangle?
is 31 degrees. And if you drew this triangle properly, wow. You can say, remember in my previous lesson once again, your vision, you can argue, is parallel to the floor. So this and that is straight. Which means we have 2 triangles.
Wait.
You see what I'm saying?
Yeah.
It's gonna happen. And which side between those 2 triangles is common?
What's that?
The height
Or the 75.
Yeah, it's 75. Exactly. Yes.
7. Wait, what?
Was that sheet given on Friday when the science field trip was?
Possibly.
Okay,
I think so.
I don't think I have.
Yeah. Compare.
What do you mean the common is 75? What does that mean?
Oh, it means this line of 75 means the base of that triangle is
Yeah.
75, as well as the top portion of the bottom triangle is 75. So that 75 actually is one number, but actually serves both triangles. That's going to be a key part of your calculations. What are they asking for? What is the height of the taller building? What is that?
Oh, it's another triangle. Is it?
Yes, but the only technique you know so far is SOHCAHTOA, which means we only can work with right angle triangles.
Oh, but that's like the cosine and sine of that.
Yeah. So here is one triangle, and here is another triangle. How can both triangles help figure out the total height? Michael?
If you have the height of where the person's standing, you can just subtract that from the height of the building and find both sides for each of the triangles.
That's one way to do it, yeah.
What?
You can use a triangle to figure out the height of, I'm going to call this H1, height 1 of the smaller triangle. And with the thing of the same breadth, you could probably figure out the height of the second triangle. And that should be the total height of the
But how do you find that height of each triangle? Yeah.
question.
1031 and 10.
Yeah.
So if you can't see the triangles just yet, I'm going to do this one time. All the other ones you're going to get to do on your own, okay? This is, you know what?
You're actually fine. Just stay out.
What do you do?
You're chaotic.
Yeah, why are you pressing on John like that?
Ali.
Yes? Oh,
Do you
I
see
get
it?
it. Yeah, I see it. Oh, and then you do the one tan.
So remember earlier in this chapter I said people with the spatial thing, people having a hard time with the B and the D. It's that same idea. Just look at it. Some people be like, I see two triangles. Other people are like, I see two buildings. What am I supposed to do with them? Okay? It's that different. Just keep chewing on it, keep an open mind, and look for those right angle triangles, because once you do it, SOHCAHTOA is going to solve all your problems.
Wait, and then you do, and then that the height of the x, right?
Yeah, so let's call this x. We have, from 40 degrees, we have the opposite side, we have the adjacent side. So setting up the equation, O and A is?
Tan 40 equals.
Yep. And 40 is opposite over adjacent. And someone please, I'll do the algebra portion. Can someone please plug that into the calculator? Well, that's what?
62.93.
So x is equal to 62.93. I'm going to assume that's meters. I did not look carefully. Yes, 75 meters apart. 75 meters apart. Next part, I am looking for this portion. Let's call it a different letter. How about we call that? No, not A. B. We have this angle. That is my opposite. That's my adjacent. Hey, look at that. Coincidentally, they are both going to be tangents.
It's 45.06.
Hey, John, shoot it down.
Yes, John. 45.06. So, what's the total height? You simply have to add 62.93, 45.06, 108, or 107.99, which is about 108 meters tall. Not the biggest building, it's about the length of one or portion of a football field, like 100-meter dash, right? But there it is. So two triangles helping us get to something that would otherwise be a little bit more annoying to calculate. So think about it this way. Not that you would do this realistically, but let's say you were in fact interested in a particular height. It's really hard to measure the height of something because it's, you'll need like string, you'll need rock climbing equipment, you'll need something, right? If we have the ability to measure an angle and we know a horizontal distance, it's a lot easier to measure. Everything else is opened up for you.
Well, that's a real life scenario.
Well, it makes certain scenarios easier to work with, that's all. Would you actually go about using trigonometry to measure the height of something? Maybe, but it may not be the most interesting practical situations. Okay, next. That's number 9. Number 9. I'll give you a minute once again. Please read the question carefully and try to draw the scenario.
Fun fact for how I answer.
No,
Yeah,
no.
she's a robot. Oh, really?
No motion.
No
Actually,
emotion.
She used to crumple my work in front of me. Like I handed it to her, she'd be
Yeah.
like this and she'd throw it away, and I'd be like,
It's an
it's
H.
not even a bad sign, but it's couldn't. There's no bench, there's not a single one.
We did good because we had the last.
Yeah, it is 78.
Yeah, she
Even I told Mr. Henblood in her class, and he's like he was like, no. I dropped the bus. Like I went to the five.
Wait, so you went in and you just handed your work to her?
No, because I handed it late. Like, I was like, yeah, sorry, I wasn't here last class. And that was on this due, so I'm handing it to you now. Sorry, like it's late. She goes, no, send it to me.
Yeah.
And I worked on that all Monday. I still have my home.
So let's do that.
Like I used to really do, and I'd be nice. Say that I cleaned it.
I know the conversation must be really, really exciting. I'm sure it is.
Disturbing.
But
Which one was this class?
this is the next question.
9?
Okay. So again, to me it's the same stuff, but to you, it might not be. Okay, the scenario will have different triangles. So this is a scenario. There is a house. There's a squirrel on it. We got two people staring up at it. How do I know that?
Are they looking?
Angle of elevation.
Are they looking at this? Are they on the roof or is the squirrel? The squirrel's on the roof. Oh, they're looking up. Sorry. Well, they could be looking up on the roof. Or at the tree.
From a tree? Possibly. You're right. There's not wrong with that. Okay. They could be on a tree. You just forgot to. There's squirrels flying. Okay. So here it is. Jesse has an angle of elevation. Jack has an angle of elevation.
So it's the same thing. As
60 and. Oh wait. Sorry. I made a mistake. Jesse is looking up at an angle of elevation of 60.
Oh, and the squirrel's looking down.
Okay. The squirrel is looking down at Jack with an angle of depression of 40. Does that make any sense?
No.
That doesn't make any sense. My bad.
No, the squirrel's looking at Jack with an angle of depression of 40.
I know. But if I think about it, the numbers don't make sense. Can we change that?
Sure.
The angle of depression, let's just make it a simple.
2.
Angle of depression, let's make it 10. Okay? So this is a squirrel's angle of depression.
Mr. Kim, it makes sense. I did it.
No.
What'd you change it to? What'd you change it to? They had the 10.
It wouldn't make sense. Jack would not be behind Jesse if that was the case. That's my bad. Okay? So if that is a 10 and this is a 60,
Oh, I'm looking at number 11.
can you see the two triangles?
How far is Jack from Oh my god, this is hard.
Do you make these questions on yourself?
Yes.
Do you actually?
Yes. It's really not bad.
Wait, you write this whole thing by yourself?
It's not as hard as you think.
That's. Wait, are you filming right now?
Yes.
So can you just hear everything we're saying?
There's like multiple head busts right now. It's like, wait, what? You write your own homework. Wait, what?
You see it? Yeah, all the talking, I hear it all.
So does it go onto YouTube?
Yeah, but if it gets too chatty, I'll probably just censor that part out.
Censor the part where we're talking about.
Dr. Jen.
Or just go back. Or just go back.
Mr. Kim, I have a question.
Actually, put it on YouTube. I want you to know how I feel. Please, just do it.
People, I'm not going to use my YouTube as a way to spread.
Now that we're on the other side, this side behind us.
No, just hold on. Let me just do this. Okay, listen up.
Keep going.
Ready? That 10 degree, I'll talk about it. That 10 degrees, it doesn't help me yet unless I make that connection. How does this 10 degrees translate into the triangle? Very quick. It does. Think about it. 10 seconds.
Oh, I don't know.
Okay. Someone going once? Going twice? Yep.
Oh, that will help. But you have to, at first you have to find. See, so no, that's 9 degrees. You know, it's 60. Like.
Oh, no, let's focus on that 10 degrees. How does that 10 degrees help with this triangle?
Oh, because it's like, isn't it? Oh, never mind.
Come on.
I was thinking it's like the opposite of the bottom triangle.
This is the floor, correct?
Yeah.
This dotted line is the horizontal vision of the squirrel.
It's parallel.
They're parallel, so therefore by parallel line here we can argue that that's 10 degrees.
But they're not that way though. It goes.
Oh yeah, that would be, wouldn't it?
Is that better?
Wait,
Yeah.
The same thing. It's just a symbol. Remember, those arrows are just symbols saying that they're parallel.
Yeah, that wouldn't that be 10 degrees? Because if you draw that, like the rest of that line out,
Mm-hmm.
it's like it looks like the opposite of. Like,
No, that's what I'm saying. That's 10 degrees. Okay? So with that, what are we looking for here? We want to find the distance between Jack and Jesse. Any thoughts? Yeah?
We're trying
That's
to
good.
find the length adjacent to 10.
Yes, length adjacent to 10. Then what?
Add it to the. And then. No, but you also need another length.
Yes, you do.
You find the length.
What's the other length? So you found this. I only want this part. How do I get rid of that part?
Wait,
Subtract
how long is that whole area together? Like, how long is that whole length?
The whole length, we can figure it out. You just told me you can figure that out. Right?
How can you figure
Yeah, by the 15 meters in the degree,
Oh boy.
you can use it.
Okay, so here's a challenge. Let's get to it. Let's start with where Mia was pointing us to and figure out the distance.
Tangent.
of
I'll use
that.
tangent.
So this is, from here, opposite, adjacent. Tangent of 10 degrees is equal to opposite over, how about we call this B for base, okay?
which one?
Now B is the denominator. But by now I'm sure you know how to handle a denominator, right?
Cross.
Yes?
Well, can you do the tan, what's tan after that?
I do not know. Not yet, at least. You can plug it into the calculator.
Yeah, it's on
Good?
So you have to find the tan of 10 is 0.118.
Okay.
0.18 and
How do I get rid of the denominator?
I give it.
you have to bring b over. You have to bring b over to
Yes.
10, so it'd be tan
Right.
is equal
That's
to
so
b.
much harder.
Or tan b is equal to 15, and then you have to divide tan,
Right.
and then you would have to divide 15 by 0.18,
Which is
which is
100 and
83.3.
what? Right?
Oh, yeah.
15 divided by 0.
0.18.
You should be a big number.
I have a question.
Try again.
Yep.
Can you not just do this? So, tan, whatever that is.
It's 83.
You put it there,
Yeah,
okay?
83.3.
83.333. That's 80.
No, it's okay. So I'm going to be a lot bigger than that. Anyways.
Okay, okay.
What's your...
Can you not do, so tan, whatever, I don't know what that is, and then switch it with B, so put that as the denominator, do 15 divided by that, and then.
Well, yes, you are switching. You are switching, but why are you switching? It's not magic.
I know, well, it's just a nice, easy shortcut.
The reason you're switching is because of what we have just done.
Yeah, I
We're
guess.
simply multiplying to get rid of the
Yeah,
denominator.
it's just lots of stuff, yeah.
Yes, but if you are passing on that shortcut to your next generation without explaining why, they're going to be lost.
Yeah.
I think magic is what math is, which isn't. Which is not true. It's not magic. Okay. Look. Okay. We have more of a picture. This, Mia, is 83.3.
Yeah.
How do I just get this portion?
Find
How do I
the.
get
You
rid
have
of?
to find, you have to get the 60. You have to have a 60-degree angle.
There you go.
And you just subtract it.
There you go. So you see how the connection happens? Okay? Look for the commonalities. When you have this this length, it is a piece of that larger length. There's a stupid example. You got like a 2-pound chocolate bar for Christmas, and then you come home one day and like 1/3 of it is missing because your younger brother like got to it or something, right? What do you have left? It's that same idea. You get what I'm saying? Okay? So you have a certain amount, you're taking away a certain amount to see what's left. You have a certain amount, you're taking away a certain amount to see what's left. Okay? So we have that. Let's work this out. Tangent of 60 degrees is equal to 15 divided by, what do you want to call this one? X? Let's call this X. Okay? That means X is equal to 15 over tan 60. That's Isabel's shortcut, which is actually just algebra.
Tan of 60 is 1.73. So
Okay, so it'd be
15
divided by, just close to 2, so maybe 8 point something? 9 point something?
8.67.
Okay. So, the drawing is not to scale, but if this is 83, that is 8.6. How far away is Jack and Jesse? Work that out. 75, 74 point. 63.
74, yeah,
Okay, so the gap is approximately 74.63 meters behind Jesse. Every single question that we do, every single question that you will see, will somehow relate two triangles together. It's my expectation for you to be able to look at a situation and puzzle your way through. It's not necessarily math, it's more problem solving. Okay? Because every question is a little different, and by the time you solve it, the math is all the same.